So this talk is really about secrets and identities, how you can give virtual machines or other compute resources multiple identities and use the different identities to give access, to restrict access, or give access to different resources. And so in this case, I've got 3 different identities. We have 2 virtual machines talking to a Cosmos database. And in this case, I would like these 2 machines, but not the 3rd machine, to have access to Cosmos. And so we're going to create an identity that will give us, and I'll discuss this a little more in a minute, give an identity to both these machines that gives access to Cosmos. I also want to encrypt some data before I put it on the Azure on a service bus here. And just to be clear, this is all done with Azure, but it works exactly the same in AWS, and I've never really worked in Google Cloud, so I don't know. So in this case, we have encryption keys, and the second machine is going to send a message to Azure Service Bus, and it's going to encrypt that data using an encryption key that's in a key vault. And so in that case, we're going to give it an identity, a second identity. So this machine is in both these bubbles. It's got 2 identities, right? And so one of those identities gives it access to the database, and the other identity gives it access to the encryption key. And so any other resources we wanted to have the encrypt permission on that virtual machine, we would give it that identity, right? And actually this part here I've done in AWS. It looks like it works the same in Azure. So in this case, that would put it on the service bus. Now we have another virtual machine. What I'd really like to do is have an identity just for it. And that identity would be different than the ones up here, because this one's only going to have decrypt permission on that. So when it reads from the service bus, it will actually have decrypt permission for that message. And that same identity in this case is going to be applied to a partner secret. So over here on the left side, we've got 2 secrets and an encryption key, and these represent policies. So in this case, what we're going to do is this connection secret, right, is going to have an access policy tied to it. And that access policy is going to be get policy. And we're going to bind that policy to this identity here. So both these machines will get access to this connection secret because they'll both be bound to this policy. And I'll show you what this looks like in a minute, right? And then the same thing is going to happen here. We have an encryption key, and we've got encrypt and decrypt permissions based on it. And so in this case, this identity is going to be bound to the encrypt permission or policy on that encryption key, and this one's going to be bound to the decrypt. And the same identity is going to show up down here for the partner select. It's going to be bound to partner select with get permission. And in Azure, we do some of this binding restriction. It's actually at the key vault level, and I'll show you that in a minute. So some of these might end up in different key vaults, right? And because everything in the key vaults kind of got, well, that's not really true. And that'll give you an idea, right? So let me show you here kind of what this is going to look like in the Azure world. We have a subscription. The resource subscription's got a resource group. That resource group has a virtual machine applied in it, and it's got a couple of identities. And in Azure, you get system identities and you get managed identities. I used user managed identities for the code sample. So in this case, the managed identity is given permissions on different resources in the different operations in this key vault. And so when the virtual machine needs to get access to the secret, it presents its identity to the key vault, and the key vault will decide whether it can retrieve that secret. There's also always another, well, not always, pretty much always another identity for a virtual machine, and that's the system identity. So in this case, we actually gave 2 identities to this virtual machine, which here you can see this virtual machine here has 2 identities. Actually, it would have 3. It would probably have a system identity as well. And so the idea here is that we can give the identities which have access to different secrets. We can get more fine-grained control about putting getting those access to those secrets or resources to that machine. And again here, these could be encryption keys or secrets. That tend to be the 2 main things that are kept in key vaults. So we have a subscription with a resource group. In the code example I've got here, all this is sitting in the same resource group. We'll have a virtual machine, an identity, a key vault, and access policy, and a secret. All right, so I'm going to show you what that looks like. So here we did this, and actually this all came out of this repo here, the ephemeral disk encryption, which is going to be a whole series of talks, but the part of this we're talking about today is just managing the secrets. Okay, so if we come over here and we can see that we actually, the things that matter here is we have a virtual machine and we have a user defined identity, user assigned identity, and we have a key vault, right? So if we look at the key vault, we can see here in the key vault, I've got a secret. And so in this case, it's SN, secret. I don't remember what the N was, but anyway, it's a secret. And you don't see that here. If we look down in here, you don't see it because the secret's actually in the key vault. It's a managed resource for the key vault. So we can see we have a secret in this key vault, and also we have an access policy here that says the user assigned identity for this is actually got an access policy in this key vault that for secrets. So right, this is key permissions and this is secret permissions. If we look at the secret permissions, it's got get and list. So if a machine presents itself as this identity, it can see all the secrets and it can get them, but it actually doesn't have access to any of the keys to do encryption and decryption. So that's actually, you can see the various permissions for cryptographic, for encrypt and decrypt here, but the one we're really talking about is secrets here. So in this case, what we've got is we've got a user assigned identity, which we looked at, and we have a secret in that key vault, and that user identity has been given the get and the list permission. So let's go back to that here. So you can see that again, use UAI, user assigned identity in this case, has access to all secrets in this vault to do a get. So you got to manage your vault kind of too, because these permissions apply across the vault. Okay, and then if we look at the VM, so we've got this VM, the VMLux example 12. In this case, we can see that an identity has been assigned to the VM. So that's this piece here again, right? We have an identity assigned to that VM, and that identity, so whenever that machine is brought up, it will have that identity, okay? And you can have system identity, and you can have as many user assigned identities as you want. So if we were to come back and we were to look over here, this virtual machine would actually have two user assigned identities here. But in this case, it kind of looks like we built this one here with a single identity, user assigned identity. And so we have that user assigned identity to that VM. And then in the key vault, we can see that that identity has get permission on the secrets. All right. And all of this is actually done in this repository here. There's a code example. So if you look in that code example, in that directory, you'll find this particular number 2 file here actually creates a resource group. It creates a key vault. It creates a secret, in this case for Lux encryption, which is different talk. It creates a user identity, assigned identity. And then when we run the next script, we actually create the VM, and that VM is assigned that identity. I think that's what this one is here. If you look here, so in this file, which is number 2, it's the, you can see we create a resource group, we create a key vault, we create a secret, we create a user assigned identity. If we go and look in the third file, which actually creates the VM, and I apologize for the size of this. Actually, you know what, let's make it a little bigger. We can create a VM, and the important part here is we give that VM this user identity. So that's it. If you look in this repository, you can find the files that we talked about, and it will implement this kind of topology for a single machine. And this is actually what it does in Azure, and you can see that in your resource group when you run it. And that's it. I hope that's useful in 10 minutes or less.